All right, 6.3, Chapter 6, Section 3, Solving Quadratic Equations by Factoring. We have been factoring a lot. We did a lot in Chapter 5. The factoring we'll be doing now will lead us to our roots of the quadratic. That is the point where our parabola crosses the x-axis. We're going to go over that a lot here in a minute. But first we're going to talk about zero product property for any real numbers a and b. If a, b equals 0, then if a equals 0, b equals 0, or both a and b equals 0. In other words, for a product to be 0, at least one of the factors must be 0. Alright, so next key concept on page 301, we're obviously not going to go to 301, I have it right here. If x plus 5 times x minus 7 equals 0, then you must set x plus 5 equal to 0 and x minus 7 equal to 0. If x plus 5 equals 0, then x equals negative 5. If x minus 7 equals 0, then x must equal 7. So the solution is x equals negative 5 or 7. So, here, hold on, let me look at, alright, perfect. So, if we had a graph, if you look over here to the left, this is obviously not going to be exact, but if we had factored and gotten x plus 5 times x minus 7 after we got done factoring, and we solved for x, and we got negative 5 and 7, without actually graphing it, I would know that my parabola is going to cross my x-axis at negative 5. 1, 2, 3, 4, 5. Sorry, right there. And I know that my parabola would be crossing the x-axis at 7. 1, 2, 3, 4, 5, 6, 7. Obviously, this isn't to scale or perfect, but it would be something like that. All right. And again, that is called the roots of the quadratic. All right. Negative 5 and 7 are our roots of the quadratic. All right. Next example, if we have x squared equals 6x, well, our first step is we always need to get everything on the left side of the equation. So here, I would subtract 6x, and I'd have x squared minus 6x equals 0. So from here, I've got two terms. First step in factoring, refresher, is always to look for the GCF. So in this case, our GCF would be x. So I take out an x, and I'm left with x minus 6 equals 0. Okay? Well, that's perfect. Now after I've completely factored it, I'm going to take all of my factors, in this case I have 2, and set them equal to 0. So I'll have x equals 0, and I'll have x minus 6 equals 0. Well, x equals 0, you're done there. X minus 6 equals 0, I got to add 6. So I get x equals 6. So the roots of my quadratic are x equals 0 and x equals 6. If I graphed x squared minus 6x, if I put that in my calculator, it's y equals x squared minus 6x. That graph would cross the x-axis at 0 and 6. Okay. B, again, I need to get everything on the same side of the equation. I'm going to get it all on the left side, so I'm going to subtract 15, and I'll have have 2x squared plus 7x minus 15 equals 0. Again, first step's look for GCF. We don't have one here. And so I have a is greater than 1. When a is greater than 1, we do the AC method. So I will do 2 times negative 15, which gives me negative 30. Two factors of negative 30 that add to give me 7 are going to be 10 and negative 3. All right, 10 times negative 3 is negative 30. 10 plus negative 3 gives me 7. So I split my middle term. I split 7x, I make it 10x and negative 3x and minus 15. So now I've got 4 terms. Whenever I have 4 terms, I factor by grouping. Boom, boom. GCF of my first group is 2x, leaves me with x plus 5. GCF of my second grouping is negative 3. That leaves me with x plus 5. So I have 2x minus 3 equals 0 as one of my factors, and I have x plus 5 equals 0 as my other factor. Okay? So from here, solve for x. I get x equals 3 halves. Solve for x. X equals negative 5. So my answer is 3 halves and negative 5. Again, those are the roots of my quadratic. That is the point where that parabola would cross the x-axis. It would cross the x-axis at 3 halves and negative 5. Okay. Next section. Don't worry about that. Another example. All right, I've got x squared plus 6x plus 9. You have plenty of room at the bottom of your sheet to go ahead and do this next example. X squared plus 6x plus 9. I got 3 terms. All right, a equals 1, so I just need 2 factors of 9 that add to give me 6. Well, that would be 3 and 3, right? 3 times 3 gives me 9. 3 plus 3 gives me 6. Well, I'll set them both equal to 0, and I'll get x equals negative 3, right? Well, it's not going to equal negative 3 twice, all right? It's going to, it just equals negative 3 once, because if I graph that parabola would just be touching negative 3 once, and it would not be going through the x-axis at any other point. It would just come through and touch it right there. Okay. A good example to look at why you get one number. All right, we also need to be able to take our roots and work backwards and figure out what our original quadratic was. All right, so if you're given the roots a, b, our formula is to do x minus a times x minus b. All right, so we would have a binomial times a binomial, so we would FOIL to get back to our original quadratic. So, if you had a problem, and I gave you 2 and negative 4, all right, 2 and negative 4. If I asked you to give me the original quadratic, you would do x minus 2 times x plus 4 because minus a negative 4 makes that plus 4. From there, I would FOIL. First gives me x squared, outer 4x, inner negative 2x, last negative 8. So my quadratic would be x squared plus 2x minus 8. Okay? X squared plus 2x minus 8. Let's say I gave you the roots of 2/3 and 3. All right, again, I would use the same formula, x minus a times x minus b. So I would do x minus 2/3 times x minus 3. Then I would FOIL. First, give me x squared. Outer, give me negative 3x. Inner, negative 2/3 x. Last would give me plus 2. It'd give me plus 6/3, which is 2. All right, we have fractions, right? Fractions a little different. So I can do negative 3x minus 2/3 x. That would give me x squared minus 11/3 x plus 2. All right, in standard form, quadratic form, I can't have fractions. So I would multiply the entire thing by 3 because 3 is the denominator of my fraction at b. Multiply the whole thing by 3 and it would get rid of my fraction. It will give me 3x squared minus 11x plus 6. I got my quadratic. Okay. Alright, so I got one more example for you. Go to a new page. Give myself a different color. Let's go pink. Alright, so if you turn your sheet over to the back, this will be your homework. Well, some of these numbers look big, and I don't want you to just not do them because you're like, oh, Coach Burris, they're big numbers, and not even try. It's the same factor we've always done, okay? If you look at number 15, we've got, here we go, 15. We've got 2x squared minus 250x plus 5,000. Okay, so our first step whenever we factor is to look for the greatest common factor. So in this case, my GCF would be 2. So I take out my 2, I'd be left with x squared minus 125x plus 2,500. Okay, so from here, I now have a equals 1, so I don't have to do the AC method. All I got to do is find 2 factors of 2,500 that add to give me negative 125. All right, well, obviously, this is can be difficult to just do in your head, right? So you want to take out your calculator and do some different factors, multiply to get 2,500, divide. All right, figure it out. This is not impossible to do. So with my calculator, I was just looking at some different factors. All right, first thing I did was I divided 2,500 by 25. Okay. And when I divided 2,500 by 25, I got 100. So 100 times 25 equals 2,500, but that doesn't add to give me negative 125. If I do negative 100 times negative 25, that would add to give me negative 125. So, because a equals 1, that's all I needed. So, I've got 2 times x minus 100 and x minus 25. By the way, these are all equal to 0. Sorry, should have had that in there. So now I set all of my factors equal to 0. So I got 2 equals 0, x minus 100 equals 0, and x minus 25 equals 0. That's obviously nothing. Add 100, add 100. X equals 100, add 25, add 25, x equals 25. So again, those are the roots of my quadratic. All right, that parabola, if I put that in my calculator, would cross the x-axis at 125. Not too bad, right, when we're following our rules. Not too bad. Alright, so next, I will look at number 24. Number 24, I've got 7x squared minus 36x plus 5 equals 0. Alright, look for GCF. There isn't one here. So A is greater than 1, so I have to do my AC method. I'll do 7 times 5, which gives me 35. Alright, 2 factors of 35 that add to give me negative 36 will be negative 35 times negative 1, right? If I add those two numbers together, I'd get negative 36. So I split my middle term with negative 35x and negative 1x. I got my plus 5. Got my 7x squared. And now I have 4 terms. So I factor by grouping. GCF of my first grouping would be 7x. That would leave me with x minus 5. GCF of my second grouping would just be negative 1, so that becomes x minus 5. And so now I would have 7x minus 1 times x minus 5 equals 0. Set up both my factors equal to 0. 7x minus 1 equals 0. X minus 5 equals 0. Add 1. Add 1. 7x equals 1. Divide by 7. X equals 1/7. Add 5. Add 5. X equals 5. So the roots of my quadratic are 1/7 and 5. Not too bad. Who cares if the numbers are big? You know how to factor. You have no excuse for not doing this homework. Okay? Remember, always look for a GCF first. A lot of times it can bail you out from doing the AC method. But if A is greater than 1 and there's no GCF, you need to do that AC method. So you got plenty of work to do. You have an in-class assignment for Kahoot. Go to Veracross, and on Veracross there's a classwork assignment. Click on it. At the bottom of the page is a link. Click on that link. When you do the Kahoot, put in your own name so that I know you did it and I can give you your points. It will tell me who did it, but if you use the nickname Pretty Unicorn, I don't know who Pretty Unicorn is, okay? But if you use the name Aaron Drum, I'm going to know that that's Aaron Drum, okay? If you use the name Grant Stacy, I know who that is, okay? None of those silly names that y'all like to use. So that's all I got. Do the Kahoot. Do your homework assignment. You should have that all done. And once you're done, be good for Mrs. Peden. And I will see you guys at some point next week. Bye.